Good morning, everyone. You are welcome in AI with Rao, and let's make AI simple. In this journey, I'm here with the most important topic, and that is evaluation matrix. If you understand this one, rest of everything will become easy for you. I bet. What are the topics that we are going to cover is accuracy trap. We will take an example and understand that the model accuracy is not everything, it's a trap. Okay, then what is confusion matrix? It's like a fundamental of all things that you learn. What is precision, what is recall, and what is F1 balancing both? Okay, so this is a generic topic that you must understand no matter what model you are using and what framework you are using. Okay, so let's start and do that with this one liner, and this one liner is this one: a test for a real disease can be 99% accurate and still catch zero sick person. The accuracy is a lie when one class is rare. Today you will learn this through matrix, precision, recall, and F1. Why I am saying this? Take an example of this, and this example here you have a diagram. You can see right now we have 1000 points, and here I'm not referring points, I'm referring here as a people. We have 1000 people, and those green are healthy. Among 1990 are healthy people, and 10 people are there who are actually sick. They are real healthy people, which is in green dots, and the person who is actually sick is being represented with this red dot. If I ask you what is the accuracy of your model, you will say 990 divided by 1000, that is 99%. Wow, this is the most accurate model we can ever create. But this is a fake, this is a false promise, this is absolutely useless. I will tell you why. Because one part or one class is present in a very rare number, and that is 10. Model will fool you. Okay, so see here, if you do the testing and it will go through all these people, can you tell me, will it actually catch those red dots with 99% accuracy? It cannot catch a single person who is sick. Now what is our objective? Is to find the people who are actually sick and tell them that you are sick. Then this is accuracy, then this is an actual result. But yet it is 99% accurate, but it is not able to catch a single person who is sick, and it can tell that actually they are sick. Now you understand the whole scenario. This is what the false promise of accuracy is. Yet it looks that it is 99% correct, but it is just fooling you. Now the question comes, how can you overcome this? How you find the actual pattern? And now I will tell you what it is. So for that we have this, we call it confusion matrix. You can see right now. Yes, this one. This is a general principle. If you follow this, you actually understand that what is actual accuracy and is model lying to you or not. It has 4 things. The top one The upper layer is what model tells, and the lower bottom two is what the reality is. Simple. And through this diagram you can see red one is the false one and green one is the actual result. So simple. With color diagram you can see what is true positive. You can see true positive, true negative in diagonal, false negative, false positive. You can always remember this diagram: true positive, true negative, false positive, false negative. Then what does it mean? See, true positive means the person was actually sick and our model caught that. This is the correct one. What is true negative? That person was healthy and we cleared that. Okay, this person is healthy. Now, what is the false one? See, this is the false positive. Person is healthy, but it alarms that no, he is sick or she is sick. Now it is false negative, sick but missed it. You know, this is a dangerous situation. Among 1000 people, we only have 10 people who are sick and we miss that. You know, this is a dangerous situation. You understand the matrix, you can remember it easily. False, true positive, true negative, false positive, false negative. That's it. Okay. Now, the most important parameter, just you need to remember not only the name but the actual context of that if I am saying what is precision, you understand that precision in terms of model. Take an example. Here is the diagram. Say precision of everyone you called sick, how many really were? What is there? 6. It called how many? When I say sick, say 6 were really sick and 2 were false alarm. You can check this. Now if I ask you what is the precision, 6 divided by 8, 75%. Now this is called precision. How precise you are. You called 8 people, out of them you falsely bring 2 people who are sick but you call them healthy, right? Then you are incorrect with 2 people. So 8 minus 2, that is 6 divided by 8, it's 75%. That's it. You can see right now when my model says sick and how often it is actually correct. This is the model calls 8 people sick and 6 of them are really and 2 were false alarm. So it is 75%. What is precision? Precision is avoiding false alarm. High precision means when I raise the flag, trust me. If you tell someone who is very precise, means what? Their error rate is very less, right? In general perspective, that's what it is. Now comes the second thing, recall. What is recall? Now let's see again. Okay, these 10 people were really sick, 6 caught and 4 missed. Among these 10 people who are really sick, we caught 4 people. Okay, you are sick, but we missed 4 people. Now if I ask you what is the recall, that is 6 by 10, 60%. I caught 60% of truly sick, avoid dangerous miss. Now what it is? See, second type question, of everyone who is truly sick, how many did my model catch? There were 10 truly sick people and model caught 6 and missed 4. then accuracy is 60%. Recall is about avoiding dangerous miss. High recall means I rarely let a rare case spill through. You might want high recall when a miss is dangerous, a miss cancer, an undetected fraud, a bomb in a bag. Better a few false alarm rather than deadly miss. You got the concept? Now the question is trade-off and F1. F1 and trade-off is, F1 is the holding, you can say, cord. Here we have high recall and we have high precision. It is just there to balance so much. If you increase recall, if your recall percentage is high, precision will drop. If precision is very high, recall will drop. And what we want in real life, we want a balance of precision and recall, and that will be represented with F1 score. F1 score, right? This is what the balancing is. That's simple. All these things are there. You can read the PDF and you can understand that. You can see the code right now. It's not a tough one. It's just simple. We took the model, predicted, and rest of the things, we precision, recall, and F1, we just print it out. And these are the confusion matrix. Truly negative, true negative, false positive, false negative, true positive. You got this point? Now, which one you should want in what situation? That is something that will make you a better machine learning engineer, a mature one. So in spam filter, you want high precision. Why? Because what do we want? Because number of spam email will be very less, and if our precision is very high, we will not spill a single mail that is actually a spam and pass through our model. So that's the reason we need high precision. Now cancer screening, we need high recall. Why? Because we never miss a real case. Because if someone has cancer and we are not detecting it, then this is a worse scenario. In fraud detection, often high recall first. Okay, and balanced problem, use F1 to keep both healthy at once. So see, this is the pro mindset. Don't ask what my accuracy, ask what does a mistake caused here, a miss or a false alarm. Then optimize precision, recall to match. That single question is what real machine learning engineer is all about. You got the context? You have to understand what is needed in my situation, high recall, high precision, or combination of both, and how all these things, matrix accuracy is false alarm. You got this point? So there, what we learn, we'll understand what is accuracy. Accuracy sometimes can fool you, model accuracy. What is confusion matrix? What is precision? What is recall? What is F1 trade-off? Okay, so thank you so much for being in the video till now.